Alright, this is Advanced Algebra, looking at Chapter 1, Lesson 6, the last chapter, no, the last lesson of Chapter 6, and we're going to look at probability. Well, how likely something is to occur. And there's two types of probability we want to look at. In the first video, we'll look at experimental probability. The second video, we'll look at theoretical probability. Now, most of the time when you're talking about probability, we're in the realm of theoretical, but experimental is an important concept to learn as well. And it's probably the easier of the two. Experimental probability, if we're going to take a look at your paragraph in the book and read that, it says probability measures how likely it is for an event to occur. So we're looking at the likelihood that something's going to happen. Now, it says you can express these probabilities either as percent, so that would be one way. So a percent is really a way to say how likely something is going to happen. And you hear this all the time if you ever watch the weather. You know, it's 30% chance of rain today, or 50%. So they're using percents to predict how likely it is for something to occur. The other way that you can do probability is to use a real number, and the thing here is they're always going to be between 0 and 1. 0 and 1 are fractions, anything between 0 and 1. And fractions, remember, are just percents. So really, percents are fractions and fractions are percents. So really, it's two ways to express the same thing. It's really not a different way. 50% is the fraction 1/2. Okay, so really fractions and percents are really the same thing. But we can look at these as percents or write them as percents or as fractions or numbers between 0 and 1. Now, the probability that this event must happen is going to be 100%. So if there's a 100% chance of rain, it's definitely going to happen. The probability of an impossible event would be 0. No chance of rain today would be 0%. So you can see that lines up with our numbers between 0 and 1. Now, this last sentence deals with experimental probability. When you gather data from observations, you can calculate an experimental probability. Each observation is called an experiment or a trial. So basically, experimental probability is where you actually take data, you actually do the probability, or you do the experiment, and then you count up how many times one event occurred as opposed to the other. The easiest way to talk about it really is flipping a coin. You flip a coin 10 times, you mark down how many heads you got and how many tails you got. So if let's say you got 3 heads and 7 tails, so the probability of getting a heads based on the experiment we did was 3 out of 10. The probability of getting a tails based upon the experiment that we did was 7 out of 10. Okay, so if you're writing those in your notes, and again you want to look at using Cornell notes or something similar, probability, you put the topic here and then you list the different concepts that we covered and then example if you have one. So probability talks about how likely it is that something's going to occur. We can look at that or write that as using percents or real numbers. If it's impossible, the real number is 0 or the percent is 0. If it must happen or will happen, the real number would be 1, the percent number would be 100. So that's experimental probability. And really, how are we going to express that? Again, we always have mathematical conventions as a way of expressing ideas and things that we have. So this in this box is very important to occur. A couple of things I want you to notice and keep and be aware of right here. P of event is very important, that when you're writing down the probability of an event is that you use this notation, P of event, and in here you put the event that you're giving the probability of. So if we did a heads minus tail, not head minus tail, heads tails experiment, and we wanted to say, okay, the probability of getting the heads was, we'd put probability of heads. If we were doing tails, we put probability of tails. Okay, so that's number one. The parentheses contains what probability or what event you are looking at in particular. Now, we noticed that, or we said that, percents and fractions are how we list probability. So I want you to notice the fraction. This is a number between 0 and 1. Fraction has a numerator and a denominator. So if we're listing our probability as a fraction, we need to know what goes in the numerator, what goes in the denominator. So if we're looking at an experimental probability problem, the number of times that you did the experiment, that goes in the denominator. So if you toss the coin 10 times, 10 is in the denominator. The numerator contains the number of times that this event right here occurred. Okay, so if we're looking at heads, we want to know how many times we got heads over how many times we actually flipped the coin. If we're looking at tails, we're looking at the number of tails we got over how many times we actually tossed the coin. If you're looking at another very common type of experimental probability that you can do is rolling a die. Okay, so how many times did you roll the die, and then how many times did you get a 1, how many times did you get a 2, 3, etc. Another thing that you can do probability events is if you're looking at sports statistics. In other words, if a quarterback was 12 out of 20, okay, for the night. So if we wanted to look at the probability based upon his performance that night of throwing a complete pass, well, he got 12 out of 20, and then we would reduce that fraction. Okay, so experimental probability, again, is taking a look at observed data. Each observation that you look at, or each time the experiment is done, is called a trial, and then the way you write that is the probability of the event occurring, whichever one you happen to be looking at, is the number of times that this event right here occurred over how many times you actually did the trial. So that's experimental probability. And so real quickly, a example. So as an example, let's take a look at a class that tossed a coin. They recorded that they got heads 161 times, they got tails 179 times. So what's the probability of getting a heads based upon that experiment? So again, the probability of the event, let's take a look at getting ahead first. Getting ahead, get it? We're going to get ahead. Getting ahead. Okay, get ahead in math by doing this problem. Okay, so the probability of getting heads based upon this experiment, so how many times did we actually get this event of getting ahead? 161 times. Over, now how many times did we actually toss the coin? Well, we need to add these two together because we got heads this many times, but we got tails this many times, so added together we got 340. So as a fraction, we got heads 161 out of 340 times. As a percent, we could then change that into a percent by doing that division problem out. So about 47% of the time we got a heads. And then if we did tails, this is the probability of getting the event tails, means how many times do we actually get this event, tails, over total tosses. 179 over, again, the same 340 tosses, or 53% of the time we got tails.